Solve each equation by using an equivalent statement. Here I have a whole bunch of examples. We did these in class, and I'm going to do them again here. And then I'm going to do some examples from your book. I'm going to start with this column first, and I'm going to work underneath it, and then we'll come back up and do the other ones, okay? So let's start. It says solve each equation by using an equivalent statement. That means use what you know about changing from a log to an exponential and vice versa. So for our first one here, log x equal 2, I'm going to rewrite it here. Log base 10 of x is equal to 2. Now to solve for x, that means find the value of x, I'm going to rewrite it as an exponential function. So this becomes 10 to the second power equal x. And 10 to the second power is 100. So I found x. X is equal to 100. And you're done. Okay? Let's do the second one. Second one says, this is number 1. Number 2 says 10 to the x power equals 29. I don't know what I have to raise 10 to get 29, so I'm going to write this as a log. Log, my base is 10, my argument is 29 equals x. Now how do I find what x is? Well, you take your calculator and you plug in your calculator you have a key that's a log key. Okay? So you take log, you hit log in your calculator and write 29, and that equals 1.4624. When we write logs, we always round off. We always round off to 4 decimal places, okay? 4 decimal places. That's number 2. So we did that with our calculator. Our third one is this one. I'm going to continue here. Number 3. It says log base 6 of x equals 2. I'm going to rewrite it as an exponential. 6 to the second power equals x, so I know x is equal to 36 because 6 squared is 36. Okay? And number 4 for that first column is 10 to the x equals 150. Let's rewrite this as a log. Log base 10 of 150 is equal to x. So again, you take your calculator, you plug in log of 150, and you get that x is equal to 2.1761. Remember, 4 decimal places. And we're done with column 1. I'm going to erase this so we can work on the other ones. Okay? Let's go back up to our second column. Here's our second column. Now we're going to work with this one. Let's do number 1. Natural log of x. Okay, let's write. Natural log of x is equal to 4. Now, the base of the natural log is e. So the base here is e. We don't write it. We know it's there. Just like the natural log, the common log, which the base is 10. We don't write it when it's 10. So when you see natural log, remember this is the inverse function of the natural number, of the natural exponential function e to the x. We know that there's an e as a subscript here, but we never write it, okay, because it's given. So I'm going to rewrite this as an exponential function. This would look like e to the 4th power equals x. So how much is x? Well, again, use your calculator. There's an e button on your calculator. It should be above your natural log button. So you take your e and then you write your exponent, which is 4. And that gives you 54.5982. Okay? That's problem number 1 here. Now we're going to do this one, e to the x equal 5. And notice, I'm going to write it over here to the side, number 2. E to the x is equal to 5. We're doing this one. Notice whenever we have an exponential form, we go straight and we change it into log form. When we have log form, we change it into exponential form. That's the trick. So this is an exponential form. I'm going to write it as a log. So this would be natural log. Remember, my base is e. This is the argument equals x. Okay? So again, calculator, x is equal to the natural log of 5. You have a natural log 5 button on your calculator, and this gives you 1.6094. Okay? Let's do number 3. Number 3, this one here, natural log of e equals x. Change it to exponential form. Remember, my base here is e, so e to the x equals my argument, which is e. Now, how can this happen? If bases are equal, then my exponents must be equal. What's my exponent here? There's an exponent of 1 here, so x equals 1. There you go. And let's do number 4, this one. I'm going to do it over here. Natural log of 1 is equal to x. We had seen this already, but let's change it to exponential form. This is e to the x equal 1. What can x be so that e raised to that number equals 1? Well, we know x has to be 0. Anything raised to the 0 power will be 1. Okay? And there is your second column. Remember, if you need to practice these more, you can go back, rewind, and do them again, and then check. Okay? Now let's go to column 3. Now we're going to work with this column. This one right here. Sorry about that. This column. I'm going to start off to the side here. Log base 10 of x. This one is very important. Log base 10 of 10 is equal to x, and we need to find what x is. Let's change it into an exponential. If I change this to an exponential, I'll have base 10 raised to the x power equal 10. So I'll have 10 to the x equal 10. So x has to be 1. If the bases are equal, the exponents are equal. Okay? So x is 1. For the second one here, I have log 10 to the 4th power equal x. The same thing. Let's rewrite this as an exponential function. 10 to the x is equal to 10 to the 4th. That means x equals 4. Now, I want you to look at these two exercises. Notice, whenever my base is equal to my argument, like in these two cases, the base of the log is equal to the argument, to the base of the argument, then the answer is going to be your exponent. The exponent that we have for that base, that's what my x will be. That's why x is equal to 1, because the exponent is 1, and that's why here x is equal to 4, because the exponent is 4. And this only happens if the base of your log is equal to the base of your argument. Okay? Very important. Now let's do this 4th problem here. Natural log of e to the negative 2 power is equal to x. Let's rewrite it as an exponential function. Remember, the base for the natural log is e, so I have e to the x is equal to e to the negative 2. Equal bases, exponents have to be equal, so x is negative 2. Now notice this is true as before. Whenever your base is equal to your argument, then x is equal to that exponent. The same thing as we saw here. Base equal to argument, x is going to be your exponent. Here I have a base of e, the argument is also e, so my exponent negative 2, that's what x is going to be. Okay? So from now on, whenever you see this, you can just write down the answer straight away without having to do anything. Okay? Now let's see this one here. I have 10 log 25 equal x. Okay, so I have 10 raised to this exponent, which is a log, and I want to know what that equals. So this is written in exponential form. Let's write this as a log. So if I were to write this as a log, I would write log of base 10, which is this base. My argument would be x, log of x is equal to, and then my exponent, this whole thing, is what goes here, log of 25. Okay, so if I have a log of x equal to a log of 25, and they are both logs, right? They're both logs, then x has to be 25. I have the same log and the same base of the log, then the arguments have to be equal, okay? Because I'm saying that they are equal. So x has to be 25, okay? This argument has to be equal to this argument. So x is 25. Notice another property. Whenever you have 10 raised to a log that's the same base as this base, your answer is the argument of that log, okay? So let's use that fact in this one. Whenever you have your base the same as the base of your log in your exponent, then this will equal, x will equal 54. I can just write it because I know that property from this problem we did before, but let's prove it. I have e to the natural log of 54 equal x. It's written in exponential form. I'm going to rewrite it as a natural log. Okay, so I can rewrite this as natural log of x is equal to the natural log of 54. Because remember, my base is the base of the logarithm. Since it's e, I don't write it. My exponent is after the equal sign. Remember that. And this x, which is your argument, is right next to your natural log. Okay? So if we want to check, I know there's an e here, I would raise it to this exponent and equal it to this x, which is what we had originally. Okay, so this is correct. Now, if I have a natural log of x equal to the natural log of 54, then it must be that x is equal to 54. If these two statements are equal, then x has to be equal to 54. This argument has to be this argument. And there's your answer. Or if you learn the property whenever you have the base raised to the natural log, then your argument is the answer. Your base raised to the common log, that's the same base, the argument of this log will be your answer. Okay? Again, I encourage you to go back, try these on your own, and then check. I will see you in the next video.